G'day folks, thanks for coming to my SauceCon talk. I want to talk today about refactoring code, specifically test code. Why should you do it? How do you do it? So stick around, we'll discuss some tips and tricks, and I'll also show you a cool tool from API Fortress that helps make code that interacts with other services a lot easier to test. So refactoring is the process where you take a set of code and you change it so that it looks and functions better without changing what it actually does. So that's great for application code, but I think you should be refactoring your test code as well, because tests are code and keeping them well designed is professional, it's good craftsmanship, and it makes them easier to maintain. Badly maintained tests become deleted tests. Deleted tests don't help anyone. The results of your tests are feedback. It's feedback that lets you know how well your app is working, and feedback is most useful when it's easily consumed and understood. Well-factored tests make feedback useful because they give you good test output and easily read code. Now, even when your tests are refactored, your framework, the things that aren't your tests themselves but that support them, that might be lots of functional code that isn't necessarily easy to read. But the tests themselves should be as readable as possible. You may have heard this referred to as damp versus dry. So dry is a software design principle which stands for don't repeat yourself. It's often what people are trying to do when they refactor their test code, well, when they refactor their application code, is to make sure that their tests are as dry as possible, that any functionality that gets used in multiple places is its own little chunk that can be reused in those places. Then you only have to fix it once if it's broken. With test codes, we want to do that, but we also want to make sure that we don't go too far. Again, tests need to remain readable. So they should be damp. They need to have descriptive and meaningful phrases. And sometimes that might mean you have several phrases that sound almost exactly the same, but that's okay. Test code needs to be readable and it needs to tell you what it's doing. Cool. So I promised to show you live code refactoring, and that is what I'm going to do. And to my displaced shame, the code that I'm going to show you is kind of janky. Sauce Labs have a Slack plugin. Now, Slack plugins work by acting as a little server that sits listening to calls from Slack, making calls to other APIs, and returning messages to Slack. Our Slack plugin lets you post job and user links into your Slack instance, and it will then unfurl it. It'll show you like, this is the name, this is the test status, here's a photo, etc. It's cool stuff, but it needed a little bit of maintenance. So I picked it up to have a look at it. And the test code is, it's special. So I'm just gonna show you a little bit of it now. The app is written in JavaScript. I'm going to be discussing how to refactor tooling based on JavaScript tooling, but all of the principles apply across basically every programming language. So this is our test code. We have one file. It's called test_app. It sets some variables up the top here. It imports some stuff. This is all pretty normal. And then it gets a bit wild. It creates its own assertions. It's good practice. We'll talk about that in a bit. And then we have a whole bunch of these describe blocks. In Mocha, the test framework I'm using here, a describe block is a way of giving context to a test. It says what you're testing, and then the it blocks under it describe what is being tested about that thing. This slash here means the root of the application, and then it should return HTML. Okay, sure. But then we've got different parts of the application should return HTML. And this part, that should return HTML. These are a lot of lines to say kind of the same thing. Then we have some stuff here about accessibility and then credentials. And oh, there's a lot of setup code in here. There's a lot of mocking. There's a lot of stubbing. In fact, you want to talk about mocking and stubbing? Let's go down to here. So this test sets up a fake token, a fake event body. It modifies the fake event body. It does something with the database. Then it mocks part of one API, mocks another part of that API, mocks a third API, mocks a fourth API, builds a request, then does a whole bunch of stuff on it, and then checks whether the mocks have worked. So that's a bit of a mess. Oh, some commented out tests. Those are always fun. Let's just skip over those. This test does the same thing as the last test, but slightly different. So that's very verbose. There's a lot of stuff here. Where are we up to? We've got 350 lines, 374 lines of test code in one file. So that's a thing that's happened. So we are going to fix it. We are going to go in and we are going to make these tests better, both because I'm going to be maintaining this app and because other people besides me are going to be maintaining this app. And the easier the tests are, like, it's not even just that we want the tests to be easy to read. We want the tests to be easy to write so that if somebody has to add more tests, they're not going, what on earth is mock.source and what is mock.ts? And I don't know much about promises and what's an unfurl. Right, we don't want that experience. We want good, clean code. So let's get started. So the first thing we want to do is we want to set ourselves up for success. In Mocha terms, that means I want to make sure that I know everything Mocha is doing, but I don't have to read my tests to know that. So one way to do that is to set up a config file, which will be used to control how the tests run. The good thing about using config files is if you change the test environment, say you go from a QA machine to a CI machine, you can just change that config file and change how the tests perform. So here in Mocha land, we need a mocha.yaml. We have one here, it's blank, which is very useful. And I'm just going to put the options in there that I might provide on the command line or in my file itself. So we have here recursive true. These options, the actual values aren't that useful for y'all. Just know that they're here to make things work the way we want them to without having to configure things in every test file. But there are a couple of useful options if you can set them. Bail true tells the test framework to exit as soon as it encounters any error. While we're refactoring our tests, we want that because we want to know if we've broken something straight away. Watch false tells Mocha not to rerun the tests every time we change them. Wait for us to rerun them because we might be changing a lot of things at once. We don't need noise in our console saying, look at all the things you've broken by editing a line. And then let's do one other thing. Let's change to a different reporter, the Nyan reporter, which is a little Nyan cat running through your terminal. Okay, so I ran these tests before we started, and I made sure we have 18 passing tests here. So the most important thing every time you make a change when refactoring tests is to make sure your tests still pass. This is a lot like when you're writing functional code. You write your tests, you write your functional code, you make sure that your tests pass, you refactor your functional code, you make sure your tests pass. We're doing the opposite. Our functional code isn't changing. So as long as our tests keep passing while we change the tests, the functional code itself acts as a test for the tests. So let's make sure that happens. npm test runs my tests. We get a fun little Nyan cat running across our terminal, and then we go, 18 tests passing. Great. What's next? Next, we want to set up some environment variables. We're going to start pulling config out of our tests. We'll continue pulling config out of our tests and putting it in something more useful. So Mocha lets me create a mocha.env file. Where I can set up some environment variables. So let's look at our tests. What have we got here? We have a bunch of environment variables we're just going to copy across. We have some environment variables that we delete. Pull those in as well. Comment all of this out. And then see if our tests still run. And they don't. The reason they don't work is because we haven't required this file yet. So they're not actually, it's not actually being pulled into our tests. So we can change that by changing our config to make sure it's required. Require / env. They pass. Awesome. So we've already improved our tests by taking stuff that isn't actually relevant to the thing under test and moving it into another file. So we can just delete all of that now. But there's another change I want to make. So we're doing these things to our environment, but if I came along and read them, I wouldn't necessarily know why we're doing that. So the next step in our refactoring to make sure we're successful is to add as much context to the tests as possible. By the way, at the end of this talk and in the chat, future Dylan will be putting a link to a set of resources that will have kind of a summary of what we did here, a link to some examples, and some other associated test code. So if you are having problems keeping track of things, don't panic, I've got you sorted. So let's make this a bit easier to deal with. I'm going to pull each variable into a little set. And then I'm going to iterate over those sets. So we can go for const. What am I doing here? In m's deleted. Delete. I'm just going to print out to the console what we've changed. And where we changed it. This way, if we run these tests somewhere and our environment variables are different, we'll be able to see in the logs what has actually changed. So we also want to say that we need to log the actual variables that we're claiming to log. That's helpful. M's, and then delete it. And this doesn't need to be a hash, that needs to be an array. This, all right. So again, let's see if our tests run. Oh, made a mistake. Invalid shorthand property initializer. Valid shorthand. Sorry. So I come from the Ruby world where we don't use JSON for everything, which means I occasionally forget to, write valid JSON. Apologies. Pro tip, writing code live, even when it's pre-recorded in front of people, is terrifying. Ooh, more mistakes. Segment right key is not defined. Oh, of course it's not, because that also needs to be a string. I'm sure this is excellent television. Excellent. Prothe is not defined. Of course it's not. That's not its name. Env is not. I'm just going to go walk into the sea. Excuse me for a moment. Okay, finally, our tests are passing again. Great. So that is our environment context. Now let's look at our test context. So what have we got in here? We have some terrible test names. We have some terrible test contexts. We're going to fix all of this. So where are we at? Describe /. It should return HTML. That's no. So what are we actually testing here? Well, we're testing the router. We're testing that when you make requests to this application, it sends back certain kinds of content. So we're not going to call that /. We're going to call that router. And then we're going to start renaming these methods so that they make a bit more sense. It should return HTML. It should return HTML on root requests. This is also testing the router, so we're just going to pull this out as well. It should return HTML, but we want it to return a not found message. Should for not found when on add requests. What have we got here? Favicon should return HTML. Well, a favicon is a favicon. It's not HTML. It should return a favicon. Actually, let's just say an image on favicon.ico. And that's it as well. Actually, we can just remove all of that. Okay, do our tests still pass? They do, excellent, let's move on. This file is way too big. It's 363 lines now that we've cut it up a bit, but that's a lot of lines. We should probably do something about that. And what we can do is we can either pull common functionality out, or we can pull the file into bits. So I think what we should do is we should pull out functionality. We should make the file smaller without breaking it up. And the reason is that I think once you identify common patterns, that makes it easier to break out common functionality. You can then move that common functionality into different parts of your application or your test framework, and then you can break the code up easily. So let's have a look at this router function. It's kind of doing the same thing over and over again. It's saying, get this, check the status, check the type. Get this, check the status, check the type. So we can probably make this a parameterized test. So we just say, hey, these are the things you need to test them for us. How are we going to do that? Well, we can add a custom assertion to do that for us. Should.assertion.add. Give it a name. Test route returns. Whoop. I need to put that somewhere y'all can actually see it. And no, this isn't an assertion. I'm an idiot. This is just our method for now. Test route. And here I'm going to cheat because I'm running out of time a little bit. I'm going to take a method I already wrote. Test route returns. So this method takes the route, the status, the content type, and the text, and it just does the checks that we're doing in these methods themselves. So now what we can do is we can go it HTML page. Type is text.html. TML. The T is important, Dylan. End that off. So if we comment that out, which is the test we've just replaced with a single line, and run our tests again, they should all continue to pass. Hey, there we go. So we can do that for the next two tests because they're basically the same thing. So we can parameterize those, as you might say in JavaScript land, in Java land. It returns a HTML error when renaming these a little bit, which is another advantage of pulling things out, because you end up going, hey, this sounds weird and I don't like it. And you can make things make more sense. This is not a URL. Status 404. So I've used name parameters here. And the reason is, again, because I want to give as much context as possible. I want people, we are checking the text good. I want people to be able to pick this text up and look at it and go, oh, I know exactly what this is testing. So if I was just to provide an array of like 200, 400 text HTML not found, you might be able to guess what it is that I'm testing, but you might not. By using named parameters here, or like an object that's been instantiated to have properties or something that's easy to look at, you make it a lot easier for people to read your tests. And that's ultimately what we're trying to do. So that's our second test. And I'm just going to go right ahead and implement our third test, where by implement, I mean, I'm going to copy and paste from my notes. Alrighty. Comment this out and check. Do we still get 18 passing tests? We do. Cool. Something else we need to try is we now need to break one of them. Because if our tests still pass after we've broken it, we haven't actually succeeded at doing anything. So let's... Cool. We get an assertion error. Expected 200 to equal 20. Because we changed something. So our tests still break. We know that our refactoring has worked properly. If we change our tests, our functional code stays the same. So our functional code acts as tests for our tests. Cool, alrighty. So I've cheated a little bit. I finished refactoring because I also want to show you how I'm going to use, or how you can use API Fortress to make your refactoring work a little bit better. So what I did in the jump is that I have split my tests into multiple files. I've refactored them a bit to make them easier to read. And now I'm just going to deal with all of these mocks. Mocks are generally not the best idea in testing. Mocks end up with test code that is crap. You end up with mocks that break and you don't know they've broken. You end up with a lot of infrastructure to keep the mocks present. It's just not generally a good time. What API Fortress can do is provide you with mocks from a live interface. So you can record them from real network calls, so you know they're right. You can easily re-record them from those network calls, so if they change, it's easy to update them. And because they're running on API Fortress's environment, you don't have to go and make sure that your mock setup works in all of your environments. It's just a server you can talk to as though it was your API. So that's great. I'm going to be doing this by recording a set of network calls, and I'm doing that from a tool called Bloodhound. So Bloodhound is a little project on GitHub. You can check it out, and the way you set it up is really easily. It's a Docker application, so you need to have Docker running on your system. But once you do, you have this Docker Compose file that you just download from the GitHub repository. The only thing I'm going to change here is I'm going to tell this proxy to run on port 8090. Bloodhound operates as a proxy. You make network requests through them, it records them, poops them out where you need them. So we've got our docker compose.yaml. I've also downloaded a configuration directory. There's a bunch of those in GitHub as well, called etc. And then in there, we configure what we're going to match and what we're going to control. So if we look in, where is it? If we're looking backends.yaml, this controls the patterns that we're looking for and what we want to do with them. So we don't need any of these default ones. Instead, we're going to define some of our own to work with Source Labs. So prefix Source Labs. Anything from sourcelabs.com, I want to go through this flow, the flow log_API. Anything for API sourcelabs.com, I want to do the same. And anything for API US West 1, etc. So now we need to create this flow. And a flow is just a set of steps to take while doing something to your network request. There's a lot of stuff you can do. You can change headers, you can change responses, you can log things, you can connect databases. But I am doing something pretty easy. Call this log.api. And all this is going to do is make the request, log that it made it, send back the response, and log that it did that. So I just need to add one thing here. So a sidecar in Bloodhound terms is just like a little extra thing that it does as well as what it's trying to do. So like logging is a sidecar because it's not part of the request. It's just a feature you add to it. Think about a sidecar on a motorbike. It lets you have an extra passenger, but the passenger can't steer or anything. So we're going to add a sidecar which forwards to API Fortress. We're going to need to go to implementers.yaml, which tells Bloodhound what sidecars it has. All this code, by the way, is going to be up on the internet, so it'll be available for you to go through at your leisure. If you want to do that, you can find it at, I believe it is bit.ly/horrible code adventures, but Dylan in the future will be typing in the chat right now to tell you what the actual address is. He's great, ask him lots of questions. Sorry, Dylan in the future. Okay, so we've told our implementer import this module. We've said just forward things to API Fortress when we need them. And now we need to add just a little bit more. We need to add some config. Everybody likes some config. So the Fortress forwarder only works for on-premise installations. So you need to be an on-premise customer. You're going to take your on-premise URL here. You're going to add app API REST v3. This here is the name of kind of your account. You can find it when you look in your, when you go to navigate through the URL for your account, you'll see what account index you have. Again, this will all be explained in the notes. And then we're just saying push everything record to the mock endpoint. The API key and secret are just generated through the UI. I'm going to delete those at the end of this so that none of you elite hackers can steal my data. And then the xmock domain value here says what domain we should be loading these from. So let's call this API demo.load2.apifortress.com. Discard response headers lets me drop things from whatever I configure. So if I now start a terminal. No, don't change Windows. That makes me sad. Terminal, create new terminal. Up. Now we get to wait for Docker to do its thing. I'm going to click my fingers and we're going to wait for the future. Cool. Bloodhound is up and running. Let us create a new terminal. Now, anything we use to request anything through that proxy address here, I'm using curl because I like it, works as it is. And if I now go and share my browser, new share, Firefox. Nope, that's not what I wanted to show you. And go to tools, mocking, and apparently log in again. Under API demo, we now have that API recorded. Here's where you can go to access it. Here is all of the status codes and responses. And of note is we can put Groovy expressions in here. Groovy is a non-compiled Java variation, to dynamically change this response. And we can add other responses as well. So we could say the fourth response you get from this API, always make it an error. Or if you include a header like fail and set it to true, then only return an error response. So this is going to be going into my test code, making it a lot more stable, a lot faster, and well, sorry, not faster, a lot faster to maintain. It will make it slightly slower, I believe, in being honest. You are now making a real request instead of a fake request. And this is a good thing, because this lets you make sure that if you have timing problems that only show up in reality, they show up in your tests now. You may want your tests to be fast, but you also want them to be accurate. So that was a whirlwind demo through test refactoring, API Fortress's Bloodhound, and how you can smack the two together to make your tests a bit faster. So if you want to see the full code and more examples, have any questions, go to the bit.ly link that you should be able to see now. That'll include a nice summary of the talk. Ask Dylan questions in the chat, which I think is over that way, and enjoy the rest of your SauceCon. Thanks very much.